Okay, it's now time for part 2 of discussing the corrosion and other effects that we're dealing with the kids' restoration process. And what I want to show you right here is, you see these worm track looking things in the steel?
Yeah, those are wild.
Yeah, you know what those are?
It almost looks like clad welding the way it's lined up like that, but they'd usually grind that smooth.
Yeah, I mean, that could be it. But what that actually is, that's the track of electrical currents trying to find a stable ground. If your ship isn't solidly grounded, you're going to pick up either electricity from the ship's electrical system, either through bad wiring, bad junction boxes, any number of modifications that volunteers could have made to a museum ship over the years, or this may not even be from your ship at all. It could be stray voltage from surrounding businesses, or even in our case in the river, passing craft on the river. Their electronic emissions are picked up in this huge antenna of a hull, and now we have stray electric voltages as looking for a ground. Now when a ship is in water, chances are, if the design is still mostly intact, she's very well grounded. But Kid has the problem of being out of the water for half the year, and she loses that ground. We did in the early 80s when they rigged up the shore power cable and wired it directly into Kid. There's a grounding cable in the middle of that power cable, but that cable is over 40 years old. We don't really have a clue of how corroded the wires are inside that bundle. In fact, we're doing a new bundle when we come back to Baton Rouge. That grounding cable in there could be corroded with a lot of resistance and not doing proper grounding. So what we have here is the result of that, and we've seen it all up and down the ship. We didn't see a lot of this when the paint coverings were on. We did see these rust blooms that we thought were superficial, you know, just on the surface of the steel. We blasted the paint away, and we found electrolysis pitting from the stem to the stern, all the way down the hull, and this has caused a renegotiation of the work being done under this contract, because we have to put our #1 priority in fixing all that pitting. Some of the pitting was so bad that we didn't know we had a leak, but the pitting was down to a bare minimum, and there was outside water pressure holding water in that was in ballast tanks and things like that. As soon as we lifted the ship out of the water, put her into dry dock,
that removes the hydrostatic pressure.
All of the ballast water that was in the tanks came squirting out in new holes, in multiple new holes that we never experienced when the ship was just sitting there in her berth.
Wow.
So this has become a very real problem. We always talk about corrosion, but we have to look at the effects of chemicals, and in this case, electrolysis.
I know Texas had a lot of issues because of the residual fuel in her tanks causing chemical problems.
Right.
And you guys have a lot of electrolysis problems. So I didn't see as much of these trackways on the port side of the ship. Is it more prominent here on the starboard side because this side faces land?
Yeah, this side had more pitting than the port side. But again, it's going to be relating to active electronic systems aboard the ship, because they're going to try, the electric currents are going to be naturally drawn to there, and then they're going to look for a ground. Oh,
that is right in line with your engineering spaces, isn't it?
Right.
Your engine room's right in there.
Right.
With your switchboards.
Right. We've got our #1 boiler and engine room here, and then we've got our aft engine room back here with the main switchboard back here.
Okay, that explains it.
So, that was a surprise and became a significant factor in this overhaul period.
Wow.
So to address these problems, we've had to take certain work line items out of the contract to free up that money to be directed to this. So if we want to readdress those same contract line items,
you got to get more money.
Please donate. please donate at usskid.com or call the museum and arrange for donation.
What did that even mean? We need an educator, somebody to talk to us and put it in normal language. So we're going to reach out to our good friend, Barry Witte. And Barry comes to us courtesy of the USS SLATER. He's a longtime volunteer on there, U.S. Navy veteran, and an educator, high school level and college level. He helped a little bit with a lot with the aftermath of the sinking of USS Sullivan's up in Buffalo in 2022. That was a sight that was just horrific to see, and we're certainly glad to have gotten Kid in dry dock before that sort of thing could happen to us. Barry also works a great deal with historic ship preservation consultants. And in that role, he came down and worked with us to get some of our electrical issues that we were having aboard Kid in the forward fire room taken care of back in January and February of this year, 2024. And while he was down here, he helped us with the electrical side of getting our anchor windlass system back up and running. So that we could go downstream and get to the shipyard and have that operable. So let's bring him on now. Barry, good afternoon. How are you?
Good afternoon. Things are quite well from up here in the Great White North, where it's snowing out, but you can't see the window from where the camera's sitting.
Well, that's okay. When I see snow, I feel cold. So I'm nice and comfy here in Louisiana. Talk to us a little bit and explain to me in layman's terms, what is electrolysis and why is it bad for ships?
Well, electrolysis is the chemical reaction of oxidation which occurs as it's accelerated by the presence of an electrical charge. And what's going on is, the entire universe is driven by chemical reactions. And the natural state of iron is not as a metal. The natural state of iron is it wants to be an iron oxide if there's oxygen present. And when we mine iron ore from the ground, we don't pull up iron ore. We don't pull up iron as a metal. We pull up iron ore, which has to go through a fairly energy intense process that reverses the energy that's released during oxidation. So, in one end of the steel mill goes iron ore, and with the investment of a lot of electricity and heat, out the other end comes iron, which, you can alloy to turn into steel. And that's what you build your ships out of for the most part. And everything's great, except the steel. The atoms in the iron really want to go back to their oxidized state. And they do so in the presence of available oxygen, which is 20% of the atmosphere. And it varies in the oxygen content varies in the ocean depending on a lot of factors, temperature and salinity and whatnot. But without proper protective coatings, the iron atoms in the steel will oxidize, and that's what you and I call rust. Right. And there's also several different kinds of metallic oxidation. And without getting into a PhD dissertation, because I don't have a PhD, but without getting into that or even getting close to that, certain metals, they oxidize in a way that creates passivity. And copper is a good example of that. You could take copper and it's bright and shiny and it's clean, and that's the actual elemental copper like you might see in a penny prior to 1982, because, it turned into zinc with a copper clad after that. And anyway, if you just leave that penny out in the elements, what will happen is it will eventually become tarnished, it'll become brown. And what you're really seeing is a very thin layer of copper oxide. And that's what gives it that brown effect. And, if you leave copper in the presence of water, the brown actually turns to a more greenish patina, which you might see on the dome of the Naval Academy Chapel, for example. Go Navy. Or it might be just a dirty penny that you find in a wet basement. But the point of that is passivity layers are like a coat of paint. They form their own protective barrier between the raw metal further inside and the atmosphere or the water where there's free oxygen. Unfortunately, iron is not one of those elements that forms passivity oxidation. The iron actually allows for penetrating oxidation, which means that the oxides of iron, rust, will fall away and expose new, elemental iron and steel inside. And, anybody that owns a car, you leave it outside and you drive up here in the salt of the Northeast, and it will, eventually your car, little bits and pieces keep falling off in the form of rust until you have nothing left. So in the context of ships, how do we want to prevent that? Okay, and really there's two strategies. The first strategy is just a really good protective coating, which is a fancy word for paint.
Right.
All right, you put a good coat of paint on, usually multi-layers. There's all kinds of different formulations of paint, and as long as you can keep that oxygen molecule away from that iron atom, the reaction will not happen. All right, but maritime environment, that's not realistic. You have touch points, in the particular case of the Kid, where the ship's bouncing up and down with the waves. When you're just at that right level of the river, the barge passes by, you get a little abrasion, and all of a sudden, maybe not the first time, maybe not even the 100th time, but eventually that paint wears away, and now you've exposed the iron to the free oxygen molecules in the water, and that chemical reaction will occur. It's spontaneous because it releases energy. The other method is to electrically protect the hull by impressing a negative charge on it. This is called impressed cathodic protection.
Right.
And what it does is it puts a negative charge, an additional negative charge on the entire structure of the hull, so that when you do get a hungry, I'm thinking hippos here for some reason, hungry atom or a molecule of oxygen heading by, it's going to grab that free electron as opposed to an electron from the iron atom. One way to short circuit that, pun intended, is to not take care of grounds on your hull. Every seagoing vessel should have a ground detection system, and this is one of the things that I preach like the gospel whenever I go to ships and try to help assist with them, including the Kid, is you need to have a functioning ground detection system, and you need to have people trained in it and checking it frequently. Active duty Navy checks grounds on every single power supply at least once a watch. Now, how often do you check them on your ship? That's a rhetorical question.
About once a day.
To avoid self-incrimination, you can take the fifth.
No. Garrett Lynch, one of our 35-year volunteers, not 35 years old, but volunteered was for 30 years. That's one of the first things he taught me when I took over out on the ship. Go check that every day. So. Right.
And that's something that, you just need to believe, like religion, that you have to, if you have a ground, you need to find it and clear it as soon as you possibly can. I mean, no, the ship's not going to spontaneously burst and fire and sink. But what happens is whenever you have a ground present, half of every alternating current cycle, you're actually accelerating the corrosion of the hull.
Right.
So I have a little graphic here. Let me see if I can bring this up. So this is off of the internet. Its image credit is Spur Chemical Corporation. But this really shows you what's going on. And in the water, you have oxygen, which can go into an area and displace a region where there's dissolved oxygen. And what you end up with becoming positive charged hydrogen atoms remain, and negatively charged carboxyl, I said that wrong, hydroxy ions will float into the water. And these hydroxy ions, they're the ones that actually want to combine with the iron. And that iron then is coming from the steel. And usually this happens in an area where you have a minor defect in the coating. So there's a little tiny nick in the paint. It might be microscopic. But as soon as that process begins, it accelerates, And it accelerates at an even higher order of magnitude if you maintain the ground, because now you're encouraging this part of the process over here to split the water molecules with the available oxygen, and that happens in the presence of electricity. All right. As a matter of fact, that's how they make hydrogen. One of the ways they can make hydrogen is electrolysis of water. So this chemical reaction is happening in water. Notice it does not happen in air. And the result are these little iron tuberculations, which you, I guess, in parks like to call the worm trails, because this process can kind of just, move along the hull. Once it starts, it keeps going even underneath the protective coating of the paint. So the bottom line here is you really, really, really need to prevent any grounds from starting this process.
So this is what Parks was calling the worm trails, worm tracks.
Yeah, that's those tuberculations or worm tubes, right?
Now, not all of this would be necessarily part of the electrolysis, and from what we were talking about earlier before.
Yeah, I think
recording, it starts that way and then can continue on by itself just as regular corrosion.
Yeah, I'm not here to tell you that it doesn't happen in the absence of electrolysis, but I am here to tell you that electrolysis will accelerate this a great order of magnitude. I mean, 100 times, 1,000 times faster. I don't have a number to put on it, but I can tell you, for example, when we took SLATER to dry dock in 2014, we didn't have this. We had some pitting at the waterline, but ever since I got a hold of SLATER in 1997, we absolutely positively maintained a ground-free hull. And when we took the ship in 2014 to dry dock, we didn't have any of this. So, witness testimonial, you keep the grounds off your hull and you don't have this kind of severe corrosion.
Now, that begs the question, would you be able to tell from these worm tracks, not necessarily you looking at the picture, but if you're in the shipyard and you're examining them up close, is there a way to tell how old these are? Because I remember these being there pretty much since I've been at the kid.
No, not to my knowledge. It's not like tree rings. There's a lot of different variables here. One of the variables is just the temperature, because most chemical reactions are related to the temperature. But you also got so many other variables, how good is the hull coating, whether or not you've got the presence of algae that's adhered to the hull, because algae is a plant and algae actually releases oxygen as part of the photosynthesis process.
Right.
So that could actually, barnacles are an animal. See, barnacles actually consume oxygen. So believe it or not, in sheer terms of corrosion prevention, actually barnacles are kind of your friend.
Okay.
Maybe, especially if they don't eat through your coating, because they're going to consume some oxygen that otherwise might consume some of your steel.
Right.
All right. But again, there's just too many variables here. I'm really surprised that those things are as prevalent as they are, because I remember walking underneath the kid when it was just out of the river, when the river level was low, I should say, and I didn't recall seeing any of that. So
this is in one specific section right around the aft fire room and aft engine room, and that's it. You don't see it. You don't see the tracks nearly as much anywhere else.
And I presume that's port side?
No, this is actually starboard side.
Starboard side. Okay.
Yeah.
All right. I mean, other localized environmental factors could have something to do with it too. There might have been something in the water at that one point, such as, the absence of a zinc anode. That's another strategy that you can use instead of putting impressed current cathodic protection on your hull, where you force electrons with an electric power supply. Right. You can also just attach a sacrificial metal that has, I guess, oxygen has a better appetite for these other metals than they do on iron. Right. So if you're in fresh water, we're using magnesiums up on the SLATER. If you look at the periodic table, magnesium is further to the left. It's a more active metal than aluminum is.
Right.
Zinc is another metal that's used a lot in the salinity. So you got ocean-going vessels, they prefer to use zincs.
Right.
Um,
And that's what Kidd had when she was brought to Baton Rouge. So obviously those didn't work that well for us.
yeah, no,
Years
just because, you go back to that image I just showed a little bit, and it's all about the iron transport through the water.
Right.
So because seawater is, it has a much higher salinity, it has a much higher electrical conductivity, which means that this kind of, pitting corrosion will happen even faster.
Right. And another factor that may have played into the creation of these, if they were created in Baton Rouge versus during her service, in the Navy, there's a pipeline running between the levee and us, underground pipeline. And at some point, they had a cathodic protection system on that. So
Now that's
maybe
interesting. Is the pipeline close to the ship where this corrosion occurred?
it's about halfway between the ship and the levee. Yeah.
Okay, so does the pipeline run up and down river or across river?
Up and down the river.
Okay, so in other words, the hull would be equal distance. So that wouldn't explain why the corrosion that you see here was localized in this one area.
Right.
Okay, all right.
Okay. Well, I appreciate you taking the time to off from your work day to come and sit down with us and try to put more of a real normal language interpretation on electrolysis for us. Like I said, you're an educator, so you put it much better than a tech versus a tech. So I really appreciate that. We want to take and thank not just Barry, but Historic Ship Preservation Consultants.
Yeah, I told her that was way too many syllables.
But you know what? It works. So you see the name and you know exactly what your business is. Remember, the USS Kidd, folks, is a non-funded state agency that receives no regular state or federal funding. So we're a nonprofit. If you'd like to support our work in the shipyard, you can go to our website and click on Support Our Mission. And you can throw all the dead presidents that you want at us, and we will take them. Our thanks to Ryan Szimanski and Libby Jones of Battleship, New Jersey, for teaming up with us on these two-parter episodes. And remember, you can visit them at battleshipnewjersey.org, and their YouTube channel is at Battleship New Jersey. And on their website, they have a link for donating, and we'll have that in the description for this video. And also thank you to Barry, the ship that's closest to Barry's heart, USS SLATER. And you can find them on YouTube at USS SLATER. Barry, thank you as always for all of your work for not just SLATER, but for Kidd, for Sullivan's, and whoever else is in need. We appreciate you very much, my friend.
Oh, you're certainly welcome. Give me a reason to come down, especially like the last week of January or February when everybody up here is really sick of winter, and I'll be right there for you.
And we'll go get tacos again next time.
Wait, we didn't get tacos the first time.
Yeah, we did. Well, I got tacos. I don't know what you got, but
I must have missed on that.
We'll get you some good food.